So have you ever tried to use Google Trends data? Say you've gone on here and typed something like YouTube because you're doing some market research or something like that, and you've looked at it and gone, wow, this is like really good granularity. I can get data every 16 minutes or something like that. This is perfect to do some machine learning on or something like that. Let's grab a month worth of that data. And you hit it on a month, and then you realize the days are actually a bit more spread out. Now, instead of being every 15 minutes, we're getting daily data. And that's not a big problem, but we need a decent amount of data. So let's go for a year. And you look at this and you're like, hang on, this doesn't look as granular. And you suddenly realize that everything is now aggregated to a week. So instead of the 165 data points that you can use in machine learning, you have 52 of them. That's nowhere near enough to build a model on. So today we're going to talk about how you can take this data and turn it into something that is granular enough that you can build a model with it. And you might be thinking to yourself, well, that could be easy. Let's just go to, say, 3 months, which is the longest window that you can get that's daily. What if I just load 3 months of data in one go over and over again and stitch them together into a time series? And so I'm going to show you what it looks like if you do that. Jump ahead to something I made earlier. You see this graph here, right? So this looks like everyone's searching for Facebook at a normal amount. You know, it varies a little bit each day. And then all of a sudden, it's about September 2021, everyone just stopped searching for Facebook, with the exception of one day when they searched for it for a normal amount, and then they just stopped searching for it again for the rest of that time period, and then everyone went back to normal. And I don't know about you, but that's suspicious that the entire world would coordinate like that. No, the reality of what we're seeing here is that Google normalizes all of their data. So whenever you load a particular window, it sets the highest value at 100 and scales everything else down accordingly. So what happened in this weird section here is that Facebook actually went down on one particular day, and that's why there were loads of Google searches for Facebook. So that was set to 100 and everything else scaled down, whereas the reality was everything was about its normal baseline. So we can't just grab 90 days and stitch them together and repeat. But what we can do is we can grab a rolling 90-day window where we move it 60 days each time, so we have a 1 month overlap, and use that overlap to calculate a scaling factor that normalizes the data together. I've broken down exactly how this works in a video, which I'll link above, to give you the kind of high-level explanation, but today we're actually going to go through the code that does it. So I'm going to take you through now, and we're going to go more or less line by line and explain how it all works. So to kick us off, we need some imports. The first one we're going to get is PyTrends. That is an unofficial API for Google Trends. It works pretty well, but you do get rate limited a lot, which you'll see in how my code has evolved. The next thing, anytime you're working with dates, you want date time, and anything that you're using APIs or scraping, you want times, just so you can set things to sleep for a little bit. You also want your favorite data frame library. So I've gone for polars in this example. Pandas is absolutely fine. We'll check the code into GitHub so you can take a look at it, and if you want, you can convert it to pandas yourself. And then finally, pyplot, so that we can plot stuff like that graph I just showed you. So here we go, line by line through the code. The first thing we're going to do is we're going to import trend request, and we're going to build a request there. That enables us to build a payload where we put the name of what we're looking for, the time period that we're looking for it, and the geography we're looking for it in. So in this case, Facebook, between the 1st and the 8th of July 2020 in GB. And then if we do this request or interest over time, then we can load the data for that time period, which is exactly what we need and is perfect until you hit all of the rate limiting problems. So the next thing I did was I wrapped it. So here we have a try and catch where I basically try and call it. If not, then I'm going to say I was rate limited on this particular date range. And I'm using all of this to log so I see what's coming out. Sleep for 60 seconds and then try again. And if it fails again, we're going to do the same thing again. So in this case, I have 3 different attempts, all with a 60-second wait in between to try and get around the fact that Google doesn't want me to grab that much data in one go. And so when I do this for a particular window, then I can load a data set and it looks exactly like what we want. So that's really good. Now, I do want to do some formatting before I can use this data. I said I'm working with polars. This comes back in pandas, so I want to do a conversion there. And I also want to add a batch number so that I can keep track of which batch of data I've loaded in that rolling 30-day window, so I can post-process it. So all I've done is wrote this little wrapping function around it, and it just reformats it. So you can see this format here that I wanted. So with that in mind, I'm going to grab a load of the data that I want, which is big names like YouTube, Amazon, Facebook, and I'm going to grab it for the countries that I want. Here I have the ability to go between term and topic. So basically YouTube will search for the term YouTube, but you can also set it so the topic is maybe the company YouTube or a YouTube channel or something like that. I've left the code in there for topic. I didn't actually find it work so well, but you might find it useful for your use case, so I left it in there. So the next thing I found was that my 2 retries, waiting 60 seconds in between, was not enough to get past some of Google's rate limiting. And the very annoying thing was that when that problem happened, I then lost all the data that I'd been running. So I made this function here that runs a subset, and it will actually save the subset so that I have it in a CSV so I can grab it later. So there's no more kind of killing everything. And that enabled me to then split up my function into a part 1, part 2, and part 3, where I had these flags here that I could turn on and off depending on what I needed to get. That would load the data in those batches and then save it in those parts there. Now, what I will say at this point is all of this code that I've shown you to load is not optimized code for this job. This is grown and developed as I've run into the problems there. And I wanted to show you it because it's very true of what data science is often like, is you spend a lot of time optimizing the actual modeling code, but the data grabbing code, you're often hacking it around to get the thing you actually need. And then maybe you'll productionize it later, or there'll be better data streams later. But there's often a lot of this putting in workarounds here that I've got. So I've left that in there. Don't take that as this is good code, you should write code like this. Take this as, wow, this is an interesting case study in how data science evolves. So because I saved it all in these different parts, I needed to write a function to combine them together. So this function here, some of them are saved in 2 parts, some of them are saved in 3 parts, some of them I managed to get in one whole. So it just pieces it together, depending on how I managed to get it, and returns it all into one CSV, which I can then load. And what I have here is just a function to load the CSV, and then also to join all the data together so that we have, you know, Amazon and Facebook and Instagram, etc., are all columns in the same table instead of just one table each. And then I also have some formatting because when I saved it as a CSV, I lost my date formats, I lost my floats and ints and so on and so forth. So this is a bit of housekeeping, load everything in, get it in the right format, good to go. So when I have all that, you get something that looks like this on my screen here. So here we have the Google Trends numbers for the dates given for each of the different terms. And like I said, if we look at the graph of Facebook, it all looks like this currently. We've not done any processing to join up that moving window so it's in the same world. So what I'm going to do is I'm going to take you through how I do that now. And this is potentially the most complicated bit, but this is the real meat of how this works. So instead of giving you the function as a whole, I'm going to take you step by step through it, and then I'm going to show you what the function looks like afterwards. So I'm just going to grab it for one table at this point, so just US because that was the first one I had. And then I'm going to add a column, and I'm literally going to call this column count and set it to 1 all the time. And that enables me to do a group by, where if I sum over the count, then it means that I can see how many of each date exists in the table. So this line here, I'm grouping by date and I'm aggregating by summing the count. So each date, I get the number of times it appears in the data. And this enables me to distinguish between dates that only appear once and then dates that appear twice. And the ones that appear twice, or maybe even 3 times, are the ones that exist in these overlapping windows. So I'm going to call them dupe dates. I'm going to remove everything that appears once because that's not a date that's used to calculate the window. I just care about the dates that are used in the overlapping window. So here they are here. The next thing I'm going to do is I'm going to take all of the data and I'm just going to filter it to the ones that are there twice. Again, I only care about the data for the overlapping window at this precise moment in time. So there we have it. The next thing I'm going to do is I'm going to do another group by, but this time I want to get for each date which of the 2 batches it's in. And I know based on how we constructed it, it's only in 2 batches, and I know they're also in chronological order. So this table here allows me to filter down to the dates that I want. So for a particular batch, if I'm working on batch IJ, then I can use this to filter down to the dates that are in IJ and then filter the data I'm working with to dates with IJ. Now you might be thinking, why do I need to do this complicated step with all this polars explode? And couldn't I just filter it based on batch number if it contains I and if it contains J? And the reason being is because when I'm looking at a particular batch, I only want 1, 2. If I filter on batch number is 1 or 2, then I'm going to get things that are in the window 2, 3 as well. So that's why we've done that here. So you'll see, that just doesn't work here. So what we're going to do, we're going to filter. Oh, there you go. There's the or that doesn't work. Sorry, that's what I was just talking about. So what we're going to do is we're going to stick I equals 1 and J equals I plus 1, which is 2 for the moment. And we're going to filter the duplicates based on the batch numbers 1 and 2. So filter this table down to just 1, 2, and then filter my duplicate data table down to the dates given by this table here. So this is going to give us what we're looking for. The next thing, what we're going to do is we're going to group by. We're going to do a group by to get the means within each batch there. So we'll get a table like this example right here, where this number is the mean of YouTube in the dates tagged batch 2, okay? Now, remember, we filtered out to only dates that are in the window 1, 2. So this doesn't include things that are in 2, 3. So this is just the mean, the average of all data in batch 2 in the overlapping window between batch 2 for YouTube and Amazon and Facebook and so on and so forth. And we have the same thing for batch 1. It's the same dates in both. This is just the mean in batch 2. This is the mean in batch 1. And this enables us to create a scaling factor. So if we take the average in batch 1 and divide it by the average of batch 2, then we get the scaling factor. So if you apply the batch 2 numbers by that scaling factor, then you get them normalized to batch 1 instead of batch 2. So this is exactly what I've done here. Because I've divided the columns together, I need to actually label them correctly. So I add a column to label them, and I just drop this batch number column because they've been divided, which works in this example with 2 and 1. But when we get to 3 and 2, it's going to give us the wrong number. So let's throw that one out there so we don't get confused. So this gives us something like this. So all of these are the scaling factor that normalizes batch 2 to batch 1's data, and we've got the 2 here to let us know that it's for batch 2. So I put that all in this function here, where I basically loop over everything we just said and save it to one big scaling factor table. Now, those of you who have been doing data science a little bit longer will look at that and go, well, why didn't you just vectorize that? And the answer is so that I could show you in this YouTube video a little bit better. So you can vectorize this. It's a good challenge if you want to improve your programming, but that's it for this video. So the scaling factor table looks a bit like this, where we have for each of the batches, the scaling factor that normalizes it to the batch before. So the scaling factor in this row 4 is how we normalize the data for batch 4 to the same scale as batch 3. And so I've got a function here that I've dubbed clean raw data, and we've gone up to here. Okay, so this is our scaling factor that we've just calculated. Now, the reason we have the rest of this function is because I don't actually want to normalize everything to the batch that came before. I want to normalize everything to batch 1. So what I really need is not the scaling factor between batch 3 and batch 2. I need to calculate the scaling factor between batch 3 and batch 1. And the way I do this is to multiply the scaling factor between 3 and 2 with the scaling factor between 2 and 1. And so this actually works out really easily in maths. I can just do a cumulative product along all of the rows of the data table, and that will give us what we need. A bit of data tidying up here, making sure that I've got all the tables joined that I need to be, and all of the columns that I want, scrub the ones that I don't want, and I get this table here. So for the US version here, I have now for every single date, I have the batch number it's in still, I have the unscaled values, I have the scaling factor, which for batch 1 is null, we don't need a scaling factor, but for batch 2 immediately starts normalizing to batch 1. And then I have the scaled data here as well. So you can see it's completely unchanged for batch 1, but on 2 onwards, it's now put into batch 1's terms. So we can take a look at what that actually looks like. So on this graph here, we have the original data with this scaled data that we have. So in orange, you see we've got the little drop down, the weird things that look like, the world stopped Googling. And then on the actual data, we have a much more normal continuous line here. So I'm just going to take that line as it is and look at it for a second. And then I'm going to compare it with the Google Trends 5 years for the same time period. And if you look at them, they look pretty similar, right? They're peaking in the same place. I double check the dates are peaking in the same place. But you might immediately say, hang on, the scale that you have, the size of your peak, is significantly higher than the size of the peak in the Google Trends data. And so you might think that your scaling factors have exaggerated the peak on that particular day, and therefore the data isn't very accurate. So remember that Google Trends averages everything to weekly. So if I took the weekly data that covers this particular time period and I average out that data, if I get something in the region of about 100-ish, then that tells me that my data is actually pretty accurate. We're in the right sort of magnitude. So I did that. I took this particular date and I took the average and I got 102.8. Therefore, we're getting something that looks like Google Trends data, behaves like Google Trends data, but gives us something daily that we can use in models instead. So this is how we took Google Trends data and turned that into something we can do machine learning with. So the code will be available on GitHub. We'll link that into the description so you can take a look at it, you can try it out for yourself, walk through it, so on and so forth. We're putting out a ton of learning resources on our website, evilworks.com, and our YouTube channel, so that you can learn data science better, but we're also building tooling that makes this process a whole lot easier so that we can actually, a lifesaver for me of this, instead of having to rerun the call over and over again and get rate limited, I could have made use of EvilWorks incremental computing on our Puff platform to not recalculate and save down the stuff that's already calculated and not redo the calls over and over again. The closed beta for our Puff platform is launching next month, so you can get a go with it, and we'll show you some stuff using that code in the not too distant future. In the meantime, if you have any questions about how this was implemented or how this works or anything like that, let me know in the comments. Please like and subscribe. If you like these videos, let us know, we'll do more of them. Thank you very much. I look forward to seeing you in the next one.